Hi, my name is Dan Gunter, and the title of my talk is Where Documentation, Cloud-Hosted Interactive Tutorials, and Continuous Integration Testing Intersect. Subtitled Slaying Dragons with Executable Documentation. I did this work along with my colleague Keith Beatty. We both work at Lawrence Berkeley National Laboratory in the Computing Research Division. So in this talk, I'm going to give a little background and describe the goals that we were trying to achieve with this, with our documentation, then give a quick overview of a couple key tools and technologies, and then describe a little bit what we did to use them and add a little bit ourselves to achieve our goals. And then I'll give a summary of everything and provide some parting thoughts. So as background, this work was done in the context of a project called IDEAS that is funded by the Department of Energy's Fossil Energy Division. It's a software framework for modeling complex chemical processes. There's a focus, at least in this aspect of the project, on power plants. It's a rather large project. It's got about 40 contributors from six different combination of national labs and academia. And there's a number of people who are stakeholders from industry and academia who are registered to interest in using this framework directly that we have a lot of contact with. So the challenges this presents for documentation is that we have multiple different kinds of users, a lot of whom are actually software developers of one stripe or another, but some of whom are users who want to use it like a tool, like a power plant operator. So these people have very different perspectives. There's a complex software stack that has underlying Python modeling code, then chemical engineering model components on top of that, and there's many different ways to extend and use this stack. And finally, there's no full-time documentation team. There's a lot of developers, but these people are either software engineers, a few of them, mostly chemical engineers and grad students who have a background in the science. All of these, though, I should mention, are kind of typical challenges in our environment in the Department of Energy. We very often, if we want to document our software, are doing so with these kinds of constraints. It's not unusual. So what actually are we trying to do? Well, we're starting from using something called Jupyter Notebooks, and I'll give more detail what those are in a minute. But what we want to do is use these as our examples, right, of how to use the framework. These are example documentation. And we want to use them for live tutorials where you can actually run and see the thing working live. We want to show the results of running them as part of documentation, static documentation. We want to provide them in a form that's usable for users on their own laptops. And then finally, we want to make these notebooks usable as a way of testing that the newest code is still correct in regression tests. So I'm going to give a little overview of a couple key tools and technologies. For those, this is a Python project using the Python language. So therefore, to generate documentation and integrate it with the Python code documentation, we use something called SPHINX, which is the most common by far approach in Python to do this. So what we have is you ends up generating HTML pages that are essentially hyperlinked pages with tables of contents and indexes and all that nice stuff that you'd expect in documentation. It's a combination of actually handwritten documentation, like you see here, with formulas and descriptions and tables, and auto-generated docs that come from the source code. And these can be kind of intermingled in a pretty flexible way, which is what SPHINX spends all its complexity and time letting you do, which is very powerful and very useful. So that's one thing. And then the other big tool in technology is this Jupyter Notebooks, right? So what are these? They're what's called an electronic notebook, which means a web-based platform. And Jupyter Notebooks are broken down into cells, so basically just a series of paragraphs that are separate. They can either each contain a markdown or some sort of markup that's rendered into nice HTML text, or live runnable code that can actually execute right there in the web browser. So the beauty of this for us is it provides an instant user interface of sorts, right? You can have Python code, but you can also have graphs and diagrams and pictures and all that sort of thing. And that's, for a project that doesn't have a lot of resources for building user interfaces, this is great. It's very powerful. and the reason that Jupyter is so popular in many projects. And it's relatively easy to create these notebooks, and they're already being used by a number of people in the development team just for their own work. It's a great way to do exploratory computing. Okay, so that's Jupyter Notebooks. And what we really want to do is we are putting all the examples of how to use our framework into these Jupyter Notebooks. So step 0 of what we're doing, I have to explain. We start with the fact that we actually have all these examples in a separate GitHub repository, which is not really a very important part of our approach, but it's an incidental thing that's good to know. First of all, if you want to go look at what we did, you have to know which URL to look at. And second of all, it's actually useful to us because the people who will be creating the notebooks and the examples may be slightly different from the core developer team. And since everything in GitHub works in terms of repositories for permissions, the ability to separate that out actually gives us a little more flexibility. And this is, I think, a kind of a big issue of documentation in general, is how you deal with the different kinds of combinations of teams you need to form documentation. So this may actually be something you have, as an audience, a lot of familiarity with. And it's useful to understand how we did something that I'll explain a little later. All right, so the first thing that we actually did to get to our goals from the kind of base functionality of Jupyter Notebooks is use something called tags. And these are arbitrary labels that can be added to each cell, which is a chunk of code or text, remember, that are essentially just strings, any sort of keyword you want to add to that cell, and you can add combinations of them. Typically, by default, they don't display, but you can tell Jupyter Notebooks to show them, what the tags are. And we created 3 types of tags. The first is called exercise, and this means in a tutorial the user would fill this cell in with what should really be done, so that you show, oh, I understand what the code should do here. The solution is, of course, the mirror of the exercise, what you should have filled in. And then testing cells mean this is only really something you'd use when you test to see if the notebook the code underneath has run correctly. For example, in this example, the degrees of freedom, once you set up your example problem, should be 0. I'm sort of making assertions, right? And we use these combinations of tags to satisfy the different kinds of the goal of different kinds of notebooks for different people. So the exercise tags are useful. We want to keep those for the live tutorials. We don't need to show the solutions, and we definitely don't need to see the testing cells. We need to tell people what they should be filling in, right? For the documentation that you put up on the web as HTML pages, this is static, it's not runnable anymore. You need to show the solution, right? Because this shows you what people, what has been done, and it'll have all the results for people to look at and browse through. For individual use, one or the other, solution or exercise, would be the right thing, depending on what the user wants to do, whether they want to do a DIY sort of approach to a tutorial, or they want to do similar to what you do with the docs and just scroll through and see all the different things that went on in the code. And finally, for regression testing, what you want to see is both the solution and these testing assertions to make sure that things are correct. So how do you get from the tags, which are all mushed together, every notebook has all these tags, to these different workflows that we have to create these different use cases? So let's say you have an example notebook creator. We created a build script that when you're editing a notebook, you can run this script, and that'll generate the documentation exactly as you would see it on the web page. And from there, the notebook creator can see whether things rendered exactly the way they're looking at them in their own notebook. And once they're happy with it, they can commit that to the repository. At that point, the testing mode kicks in behind the scenes and automatically makes sure that not only does this work with their local copy, but this works with the current updated code in the repository. So it tests everything before you finally commit it. So there's the regression testing. And of course, when that finally succeeds, you're done. For the code developer, they're not editing the notebooks, they're editing the code. So in their case, they're not looking at the documentation version, but what they want to do is the same mirror of what the notebook creators do. As soon as they commit code to the repository, we want to take that and run that with the same script against all the code in the notebooks. And then as soon as that succeeds, they can check their code in. And finally, the release manager operates in the mode of, well, we know that the code runs, but we need to generate all these documentation, not just a particular single notebook. So you use the same script to build all the notebooks and add those files to the release. So next I'll talk about how we deploy these documents. So the first mode is to deploy them online. And we actually do this in two places. The main docs, as I might have mentioned, we use something called Read the Docs, which is the common hosted environment for Python documentation and others, as from the release manager workflow. And then the examples, these Jupyter Notebook examples, we've decided to use GitHub pages with the same exact look and feel. So everything is generated with SPHINX, so it looks the same. And to link together the two different kinds of documentations, we're just using hyperlinks. Now, whether we were hosting the examples on GitHub pages or Read the Docs, it would be sort of a separate repository either way. In the case of the reason we're using this simple GitHub pages approach is essentially we're generating all the content of the HTML with our own script anyways. So it doesn't really do us any good to have any other tool doing that for us. Honestly, though, the linking between these two is a little clunky and not quite as, it's not quite as natural to have the examples feel somewhat separate from the main documentation. So there's one thing I'd like to improve. But it does work quite well. And then for deployment to the user's machines, the package is distributed in the usual Python way. But if you remember, the Jupyter Notebooks are in this different repository, which we could include in the package. But the real problem is that the package wants to install everything off in some secret installation directories. What we really want to do is just install them right in front of the user so they can access them and browse them. And so the way we do this is we added our own simple command line interface that goes and fetches the examples and does into a local directory. But then it also is able to strip all the cells with the testing tags, so we get what we wanted, which is we get the solution and the example versions of the notebooks locally. And for good measure, we also install a bunch of Python code that may be in the same directories as these examples, so that we have the examples can essentially delegate some of the more complicated or more boilerplate pieces of code to a script that you don't have to show the user. So finally, another place we deploy is in the cloud, and this is something we've done for tutorials where you take these same example notebooks that we've used for documentations and users, but we instead have a zero install way, basically, of running them. And this is perfect for if you have a workshop full of people, they show up, they have their own laptops, and you say, okay, just go here, make up your username, log in, and you get this preloaded environment. And we have an index notebook where you can go hop over to the tutorial and start running it. You know, nothing to do except just click and start and jump right into the tutorial. And this allows us to completely control the environment and with no particular load on the user. And we've actually tested this with a room full of users, like 30 or 40 at a time. And you know, given that AWS has this auto scaling feature, we have some scripts that do various nice things to scale up to more users, and it was a really effective way of getting people to just hop on and see how things look. And again, we didn't have to really modify the notebooks at all. We're just using the same ones we're using for documentation. Also, one nice thing is you can use this table of contents notebook as kind of a hook into any last-minute updates, because it's a piece of code as well. So you can add something that goes and pulls down last-minute updates and installs them. In case that's necessary. And here's where the narrator says, yes, last-minute updates are always necessary. It's a tutorial, it's live. So that's a really nice feature, actually. So in summary, we use Jupyter Notebooks as our examples to test, document, and give tutorials, serving multiple use cases for notebook creators, developers, release managers, and users. We use Jupyter tags as a way of labeling different cells within notebooks for different purposes. And then we wrote a bunch of custom code, 1 or 2 scripts basically, to handle the details of processing all this for us in an automated way. It builds the documentation and it downloads, in the case of users, the right version for individual use. So some parting thoughts, sort of stepping back and looking at it from a little bit higher above the trees. So there's some common patterns here, right? Separating semantics and presentation, in particular the Jupyter Notebook tags, gives us the power to render the same thing in different modes. We're also using the pattern of executable documentation, right? We're mixing code and docs in a single source and then allowing it to be used either as something that's static or something that you can run live depending on your context. Definitely in our approach, I would say there's currently things that I would consider warts, one of which is that we have these custom build scripts, which are something that we have to continue to maintain and make sure no one else is really supporting them, and the tools underneath, such as SPHINX, are not really aware of them, so if the SPHINX interface changes, we have to change. Semantic markup that we're using, these tags, is something that part of the reason we have to do this pre-generation is because Jupyter Notebooks don't really do any UI level understanding of the semantic markup for us. They don't sort of hide and show tags easily. And it'd be nice if there was just a way of doing that. And then translation of these notebooks to doc pages, we had to do a few little tweaks here and there, and it's just enough that now we depend on our tools to work around some of the limitations of the existing connection between the Jupyter Notebook way of exporting things as HTML and the SPHINX way of dealing with exported versions of the example notebooks. And finally, and this is somewhat specific to this project, but the separation of the examples and the main code documentation is somewhat clunky. So our wish list is very related to the warts, really, is that it would be nice to have a general purpose script that had a little bit more community support and buy-in, or at least the main part of what it does, which I think is mostly general. The idea of sort of building this in these different modes are something that other people probably want as well. It'd be nice if this just ran and read the docs or standalone easily. It's supported, in those modes. Also, for the problems of the semantic markup, it'd be great if Jupyter Notebooks sort of had built in the idea of different run modes, where you could look at different tags and support them in different ways. It'd be really great if you just plug in your own code sometimes to do that. But some standard things, just showing and hiding, would be great built in. Finally, of course, a wish list is feedback from you. Maybe there's something you saw that said, gee, there's already a tool to do that, why are you inventing it? Or maybe something where you said, I'd like to do that too, can you talk with me more about it? Either way, we'd love to hear your feedback. So that's it. I'd like to thank the IDEAS project. You can go to ideas.org to get more detail. Funded by the Department of Energy. All these notebooks that I showed you, almost everything was done by this wonderful big technical team here, which consists of 3 universities and 3 national laboratories, and quite a large team of mostly chemical engineers, but a whole mix of great people. And finally, of course, I'd like to thank you for listening. Thank you.